In the earlier chapters, we have studied the formation and distribution of land and sea or continents and oceans. The continents and oceans are considered as the relief features of the first order of the globe. The locations or the spatial distribution of the continents and oceans as we see them on the map, we have not been the same since the formation of the earth. The frequently asked questions are related to the present position of the continents and oceans, such as, do the present day continents occupy the same positions in the geological past? Do the continents and the oceans have changed or changing their positions? How and when they have changed their positions? What were their positions in the geological past? If the continents and oceans have changed their positions, then what is the driving force for the changed positions, and so on. The curiosity for these questions can be sought in the theory of continental drift. The main objectives of this lesson are to understand the present day distribution of the continents, to understand the concept of Pangaea and its splitting, to identify the forces for the drifting of the continents. The continental drift theory is an attempt to explain the present arrangement of the continents and the oceans. In this theory, it is assumed that there was no such existence of the continents as we see today. All the continents were unified in the form of only one supercontinent. The idea of drifting of the continents is quite old. The correspondence between the coastlines of Africa and South America appears to have been known to most of the explorers and navigators of the great age of discovery. As early mapping gained accuracy, some observers noticed symmetry in the western coast of Africa and the eastern coast of South America. Abraham Ortelius, 1527 to 98, described the apparent fit of some continental coastlines. In 1620, the British philosopher Sir Francis Bacon noticed gross similarities between the shapes of Africa and South America, although he did not suggest that they had drifted apart. Soon after the first reliable world maps were made, scientists noted that the continents, particularly Africa and South America, would fit together like a jigsaw puzzle. Antonio Snyder, a Frenchman, was one of the first to study the idea in some depth. In his book, Creation and Its Mysteries Revealed, showed how the continents looked before and how they got separated. He cited fossil evidence in North America and Europe, but based on his reasoning on the catastrophe of Noah's flood. This idea seems to be far-fetched for the scientific community or general public. Snyder presented his views about the drift in the year 1858 in France. Main purpose behind the postulation of drift hypothesis of Snyder was to explain similarity of fossils of coal seams of Carboniferous period in North America and Europe. The purpose of his hypothesis was to explain the problems of the origin of the folded mountains of the Tertiary period. Taylor wanted to solve the peculiar problem of the distributional pattern of Tertiary folded mountains. He explained the north-south arrangement of the Rockies and the Andes mountains of the western margins of North and South Americas and east-west extent of the Alpine and Himalayan mountains. He propounded his drift or the displacement theory. The concept of Taylor is thus considered the first attempt in the field of continental drift, though Antonio Snyder presented his views about the drift in the year 1858 in France. Alfred Wegener, a German meteorologist and a geophysicist, publicly presented in a lecture his idea that the earth landmasses or the continents migrate. His book, Origin of Continents and Oceans, appeared in 1915. Wegener, who is today regarded as the father of the concept, based on his theory not only on the shapes of the continents but also the geological evidences such as similarities in the fossils found in Brazil and Africa. He drew a series of maps showing 3 stages in the drifting process of the continents, beginning with the original large landmass called as Pangaea. The theory of continental drift is an attempt to explain the present day arrangement of the continents and the oceans. The comprehensive theory of drifting of the continents is propounded by Alfred Wegener, a German meteorologist, in the year 1912. According to Alfred Wegener, in the geological past, lateral displacement of the continental masses took place on the global order. The present day distribution of land and water was not the same in the geological past. The displacement hypothesis of continents or the drifting of the continents was based on the findings of various scientific disciplines like paleontology, geophysics, geology, paleoclimatology, etc. The theory of continental drift grew out of the need to explain the major variations of climate in the past. Wegener has drawn to the idea to explain the ancient climates of the past. The puzzling question in his minds were: 1. Why cold belts are found in the cold climatic regions of the tundra, and why glaciers have covered parts of Brazil and peninsular India, Australia, South Africa and Congo Basin at the same time, and so on. While thinking over the given points, the theory of continental drift grew out of the need of explaining the major variations of the climates in the past. He observed that there was a shift in the climatic belts of the world. According to the continental drift theory, in the geological past, equatorial, tropical, temperate, Arctic and Antarctic climatic belts were located away from the present day locations. The main problem before Wegener, which needed explanation, was related to climatic changes. There are ample of evidences which indicate widespread climatic changes throughout the world. The continental drift theory of Wegener grew out of the need of explaining the major variations of climate in the past. The climatic changes which occurred on the globe may be explained in 2 ways. 1. Continents remained stationary and there was a shifting of climatic zones. Assuming that the continents remained stationary at their places, the climatic zones might have shifted from one location to another region. Secondly, climatic zones remained stationary and there was a displacement of land masses, that is, the climatic zone remained stationary and the land masses might have displaced and drifted. Based on various evidences, Alfred Wegener got convinced that it is the continents which have drifted laterally in the geological past. It is more probable that the land masses have changed their positions. All the continents were unified in the form of one supercontinent in the ancient past, which he termed is as Pangaea. He assumed, on the basis of evidences of paleoclimatology, paleontology, paleobotany, that all the land masses or continents were united together in the form of one landmass, which he named as Pangaea in the Carboniferous period. Wegener's continental theory begins from the Carboniferous period. The Pangaea was disrupted during the subsequent geological periods, and broken landmasses drifted away from each other to their present position. The Pangaea was surrounded by a huge water body or an ancient sea named by Wegener as Pangaea. The Pangaea represent the primeval or the ancient Pacific Ocean. According to Wegener, Sial was considered to be limited to continental masses, whereas the ocean crust was represented by the upper part of the seama. That is, the continents are made up of Sial and the oceans are mostly made up of seama. Continents were Sialic masses which were floating on the seama without any resistance provided by the seama. Wegener assumed that in the Carboniferous period, South Pole was located near Durban, that is Natal in South Africa, and the North Pole in the Pacific Ocean. In Pangaea, the term pan is equal to all, means all, and Gaea is the earth or the land. According to Alfred Wegener, Pangaea was a unified landmass or one supercontinent. According to him, all the present day continents were united into single landmass, that is Pangaea. Before the Carboniferous period, that is 300 million years ago, all the present day continents joined together, which was termed as Pangaea by Wegener. The present distribution of the continents and the ocean is attributed to the splitting and subsequent drifting of the landmass. Pangaea is the supercontinent from which the present day continents originated by the drift from the Mesozoic era to the present. The Pangaea was surrounded on all the sides by an extensive mass of water or ocean called as Pangaea. The term Pangaea stands for pan is equal to all and thalassa is ocean. It is the primeval or primitive Pacific Ocean which encircles from all sides of the Pangaea. According to Wegener, the Pangaea started breaking up in the various geological periods, and the present shapes and the relative position of the continents are the result of the fragmentation of the Pangaea. The division of Pangaea took place in different geological periods. The direction in which the continental landmass drifted was also various in different geological periods. According to Wegener, the Pangaea started breaking up in the Carboniferous period about 300 million years back, and the present shapes and relative position of the continents are the result of the fragmentation of the Pangaea. The first division of the Pangaea took place in the Carboniferous era, which was in the east-west direction. It is the phase of opening of the Tethys Sea. The remains of the Tethys Sea are in the form of present-day Mediterranean Sea. Pangaea was broken into two giant parts due to the differential gravitational force and the force of buoyancy. Due to east-west splitting of Pangaea, Pangaea was divided into the northern part and the southern part. The northern part is called as Laurasia or Angara land, and the southern part was called by Wegener as Gondwana land. The Laurasia includes present-day North America, Greenland, Eurasia and northern part of Indian subcontinent. Gondwana land constituted South America, Africa, Australia and Antarctica, and also peninsular India. Gondwana land drifted apart under the impact of tidal force of moon and the sun. Wegener assumed that the disruption of the southern block of the Pangaea, that is Gondwana land, took place mostly during the Mesozoic era. The intervening space between the northern block and the southern block was filled up with water, and the resultant water body was called as Tethys Sea. The second division of Pangaea was in a north-south direction. The north-south splitting of Pangaea resulted in the opening of the Atlantic Ocean. Subsequently, the part of the Pangaea moved westward in the form of North and South Americas. North America broke away from Angara land and drifted westward due to the tidal force. The westward drift of the North Americas occurred during the Tertiary period. Similarly, South America broke away from Africa and moved westward under the impact of tidal force. The Atlantic Ocean was formed due to the westward movement of North America and the South Americas. North and South Americas were drifted westward at different rates, and hence a shape of the Atlantic could be possible. Due to the northward movement of the Indian Peninsula, Indian Ocean was formed. Arctic and North Sea were formed due to the flight of continental blocks from the North Pole. The size of the Pangaea Sea, the primitive Pacific Ocean, was considerably reduced because of the movements of the continental blocks from all the sides towards Pangaea. The remaining part of the Pangaea becomes Pacific Ocean. The southern part, or the Gondwana land, was broken in the Mesozoic era, and the northern block, that is Angara land, in the Tertiary geological era. Thus, Laurasia and Gondwana land continue to break into smaller and smaller continents that exist today. The movement of continental blocks away from the poles was called by Wegener as the flight from poles. There have been frequent changes in the position of the equator and the poles. According to Wegener, the location of north and the south poles was not constant. The north and the south poles are changing their positions from one geological period to another. The North Pole was occupying the southernmost position in the Silurian period, that is 14 degrees north, and subsequently shifted northwards and reached a position of 51 degrees north in the Tertiary period. Similarly, the South Pole was occupying the northernmost position in the Silurian period and was located to the west of Madagascar and slowly shifted southward, occupying the position near 53 degrees south latitude. In the opinion of Wegener, the continents drifted in two directions, one towards the equator and second towards the west. The equatorward movement would depend on the relation of the center of gravity and the center of buoyancy of the floating continents. Generally, these forces operate in opposite direction. Due to ellipsoid form of the earth, these forces are not in direct opposition but are so related that if buoyancy point lies under the center of gravity, the resultant force is directed towards the equator. According to Wegener, the attractional force of the sun and the moon was maximum when the moon was nearest to the earth and therefore dragged the continental blocks towards the west. Alfred Wegener identified two sets of forces responsible for the drifting of the continents. Continents, after breaking away from the Pangaea, drifted in two main directions due to two sets of forces. Equator force is the force generated due to differential gravitational force and rotational force. The equatorward movement was caused by differential gravitational force and buoyancy. On account of the equatorward force, Africa and Eurasia were pushed closer together, and the Tethys Sea deposits located between the two has raised up in the form of mighty fold mountains such as Alps, Tian Shan, Zagros, Altais, Hindu Kush and the Himalayas. The westward force was caused due to the tidal force of the moon and the sun, or the westward movement of the continents, in his opinion, was due to tidal force of the moon and the sun. On account of this westward drift, North Americas and the South Americas got separated from Europe and Africa, and the Atlantic Ocean came into existence. Wegener's continental drift theory also tried to explain the origin of folded mountains of the tertiary geological period. The frontal edges of the westward drifting continental blocks of North and South Americas were crumpled, folded against the resistance of rocks of the seafloor, that is SEMA, and thus Rocky Mountains in the western coast of North America and Andes mountain chains in the South America were formed. Between the two rafts, a trail of fragments was left behind to form the islands of West Indies. Similarly, the Alp mountains in Eurasia were folded due to the equatorward movement of Eurasia and Africa. On account of the movement of Gondwana land towards the equator, that is on account of their coming close together and the southern landmass of Gondwana land pressing against the northern landmass, the Alpine and Himalayan ranges were formed in the tertiary period in the region occupied by the Tethys Sea. While explaining about the drifting of the continents, Wegener indirectly contributed to the understanding the origin of the island arcs and festoons of Eastern Asia, West Indies and the island arcs of Southern Antilles between Terra del Fuego and Antarctica. According to him, island arcs are formed due to the differential rate of continental drift. A part of the Angara land, which includes Asiatic landmass, was moving westward. The eastern margin of the block could not keep pace with the westward moving of the landmass, which lagged behind. Consequently, island arcs and festoons consisting of Sakhalin, Kuril, Japan and Philippines etc. were formed. Some portions of North and South Americas, while they were moving westward, were left behind, and the island arcs of West Indies and Southern Antilles were formed. In this session, we tried to get an insight into the historical background of the theory of continental drift. In the analysis of the historical evaluation, it is seen that prior the formulation of the theory of continental drift, various scholars have contributed to some aspect of the continental drift theory. A comprehensive work in the form of a theory on drifting of the continents is propounded by Alfred Wegener. Alfred Wegener, being a meteorologist, proposed a theory of continental drift out of the need, explaining the major climatic variations on drifting of the continents. He gave the concept of Pangaea, which according to him was a supercontinent or a unified landmass, and it was surrounded by an extensive ocean which he termed it as Pangaea. Wegener identified two forces in the splitting of Pangaea as equatorward or the differential gravitational force and the tidal or the westward force. The fragmentation of the Pangaea took place in different geological periods. In this lesson, we have learnt ultimately how the present distribution and the arrangement of the continents and the oceans are formed.